Hello everybody. So today's video is going to be about the nearest toolbox function, which works with Granger connectivity, similar to Granger causal analysis. This is basically going to look at what channels have an effect or can predict changes in other channels. The module can be found in the advanced.nearest.modules folder, and it's just called Granger.m. Uh, it's going to compute, this is basically the comment on it, it's going to compute all-to-all multivariate Granger's connectivity model. Not very self-explanatory, but I'll do my best to explain it here. So it has several properties. It's going to be model order, name, and previous job, or prev job, which is similar to all the other functions that you can utilize in your pipeline. The model order I've found to be somewhat significant, because if you leave it blank, the model seems to run, or the function seems to run indefinitely. For this purpose, I actually used a model order of 3, mostly admittedly just because I'm fairly naive to how to run this, and 3 tends to be the default for most model orders. The methods found within this are going to be connectivity, site, Java options, run, and run this. The output will be a connectivity stats object, which you can find more info on that in the nearest.core.connectivity stats. And specifically the connectivity stats object has several properties and several methods. You'll have description, which is a file name. You'll have the probe. You'll have demographics. Variables is actually left blank, which I was unable to figure out exactly what those designate. You'll get Granger coefficients, Pearson coefficients, p-values for Granger's, Pearson or p-value for Pearson's, degrees of freedom, and then in the methods you'll have things that are actually converting one coefficient to another or one value to another, as well as the typical draw and table functions. If you were actually to run it, this will actually get it's a very simple version, but it will run the module. You can basically create a job named J, which will be called as advanced.nearest.modules.grangers, and you create it as empty. I then set the model order by saying j.modelOrder equals 3, and then I do j.run. It is run on the raw data. Technically you can filter it, but I've seen some papers that say that it's may not be advisable to filter it. Again, you can do a little more research in that realm. But then you save it as a variable, which I saved as con for connectivity statistics variable. The output will be a connectivity stats object, which is shown here in your workspace, and it has these properties. When I ran it, again, this is kind of an introduction to how to run it. I'll try to get a little bit more in-depth video on exactly what's going on and how to run it in varying ways, but you get this output. The kind of important aspects that I'll say that are the important aspects are going to be the Grangers, which is your coefficients, and the Granger's F, which is the F statistics on the Granger coefficients. The reason the size is 40 by 40 is because you've essentially created 2 models, one of which is a full model, they call it, which is essentially containing an extra variable, which will then be used to show causality or basically predict a second variable. The second model will not be including that. So it's kind of a simplified version, and then you're looking at the comparison between the two. Just as I stated here, you have the coefficients comparing the full model against the partial model, and then also an F test to designate whether or not they were significant. I hope that helps. Again, it's an introduction to the video, or to the function, and I'll try to get a little bit more detail on it as I learn myself, but at least this can get you up and running. Again, I hope this was helpful, and I will have more down the road.